All right, so cool, awesome. Hi, thank you all for coming today. I'm Sully Ross. I work at Google on controller tooling as well as autoscaling and metrics, and I'm one of the SIG leads for SIG Autoscaling.
Hi, and I'm Michael. I'm a developer advocate at Red Hat.
All right, so what is autoscaling? So basically, autoscaling is taking calculations of usage, right? Metrics like CPU, memory, or even things like requests per second, and using that to ensure that your application can fulfill its service objectives and agreements, right? So making sure that you're up all the time, making sure that you can serve requests in under a certain amount of time, things like that. So in Kubernetes, we have basically two kind of categories of autoscaling. So we have cluster autoscaling, so that's creating more nodes when you run out of space to schedule your pods onto. And then we have application level autoscaling. So that's making sure your applications themselves have enough room to operate in, and that there's enough instances of your application or your application's big enough.
Can we quickly do a show of hands at that point in time? Who's using a cluster autoscaler? All right. Who's using a HPA? OK, cool. VPA, anyone already? No? Wow.
Oh, awesome. Cool.
Nice.
Few of you. Right, so for those of you who may not be familiar, we call the Horizontal Pod Autoscaler, so that's horizontal application autoscaling, making more replicas of your application. We call that the HPA. And vertical autoscaling, that's increasing the resource limits of your application. We call that the VPA. Did you want to handle that?
I think that's good.
All right. So the Cluster Autoscaler in Kubernetes is a tool for automatically increasing and decreasing the number of nodes available. And it does this by talking to the cloud providers and actually running a scheduling simulation. So it constantly is looking at the state of the cluster, figuring out whether or not pods would become unschedulable, and if so, trying to increase the nodes. And simultaneously, if there's too many nodes and they're kind of all have lower utilization than perhaps you might like, it will attempt to figure out which nodes can be removed without violating your pod disruption budget. So without necessarily killing off a node that has some critical workloads running on it, even though it might be underutilized, because that would not be good. Right. So moving beyond cluster into the individual app level, there's also horizontal autoscaling. And so the idea behind horizontal autoscaling is that we declare a target value for some metric. So for CPU, we might declare that we constantly want our application to kind of target around, 500 millicores, half of a core. Or we might say that we generally want each instance of our application to be serving, say, 50 requests per second. And then, at a regular interval, the Horizontal Pod Autoscaler will look at the actual resource usage of our application. So maybe our actual requests per second that a single instance is serving is 100, or the actual CPU is 1 core. And we say that's too high. We're getting into the danger zone of maybe we're going to start getting performance issues. And so what it will do is it will compare those. It will form a ratio. And we say 100 is the actual usage, divided by 50 is what we have desired. So we scale up by a factor of 2. And simultaneously, if we were instead, each instance was only serving 25, we say maybe we don't need as many instances because we know from our previous knowledge that we can actually serve 50 comfortably. So 25 over 50 is a half. So we divide the number of replicas by 2. And this works really, really well when you have an application that can be scaled horizontally. It's great for things that are somewhat stateless, things like web applications. Not so great for things like databases frequently, unless you have an awesome horizontally scalable database. There are a few of those. And so for something like a database, oftentimes vertical autoscaling can be better. So the idea behind vertical autoscaling is that we look at your resource usage, and we figure out if you're bumping up against the limits that you've set, and we try to increase them. So right now, that process actually involves restarting a pod. But in the future, we hope to just be able to increase in place. And so this works really great if increasing the number of replicas won't necessarily solve your problem. All right, so in the past, the way autoscaling worked is we only really, in the past, had horizontal autoscaling. It's way back in the annals of Kubernetes history. And so what happened was we had this tool called Heapster, and Heapster would query all of the nodes and expose an API. And then the Horizontal Pod Autoscaler would go to Heapster and say, give me all of the metrics for the containers that I care about for each of the pods. And we could autoscale. We only autoscaled on CPU and memory, and then memory went away because it was hard to autoscale on, and we could only autoscale on CPU. And that was the way it was for a long time. And eventually, people said, I would like to scale on custom metrics. And we had a few false starts on custom metrics, and we eventually settled on something called the Custom Metrics API. So the idea behind the Custom Metrics API is that people have very strong opinions on how they should monitor their applications. Some people love Prometheus. Other people love Stackdriver. Some people love Influx, what have you. So we defined an API that didn't have an implementation, kind of the same way Ingress doesn't have a canonical implementation. The Custom Metrics API does not have a canonical implementation. Instead, we have these things called adapters. And adapters sit as a layer between your metric storage and the Horizontal Pod Autoscaler. So the Horizontal Pod Autoscaler can go to the Custom Metrics API and say, give me custom metric X. Give me requests per second on this pod. Or give me queue length on this object. And then the adapter will translate that into a query to Prometheus, a call to Stackdriver, what have you. And this allows us to let people bring their own monitoring and just start using what they have with the Horizontal Pod Autoscaler.
All right. We probably should have mentioned in the beginning that today we're going to give the introduction and overview, and tomorrow we will have a guest from Megalix who will talk a little bit more about predictive analytics around that topic. They have an offering there, and we also do Q&A. Today, I don't know how much time we will have for Q&A, but let's see. All right, vertical pod autoscaling, as Solly already mentioned, there are certain use cases where the HPA stuff doesn't really apply or doesn't really play that nicely. And the starting point really is if you look at this YAML file here, essentially under the resource specification where you essentially define requests and limits. And that is something that is super important and very often not done because it's kind of like, how should I know how much memory my application is going to use? So a bit of background and terminology here before we dive deeper into that. The process of scheduling is essentially part of the control plane, the scheduler there, that you on the one hand have nodes, the worker nodes that offer resources like CPU and RAM, and then you have pods that consume resources, right? And all the scheduler really does is trying to match that, right? Saying, can I find a node or nodes where the request that these resources or these pods come along with can match, and I can schedule it there. The rest is then taken care of by the kubelet on the respective node. There are different kinds of resources. If you think about memory, that is something that is incompressible. You cannot just say, okay, I'm going to randomly take some pages away and hope that the whole process is still running. Whereas CPU is compressible, right? You can assign fewer CPU cycles to a process, which still perfectly run, just slower. So you have to look at the type of resources you're dealing with here. And most importantly, the thinking here, the underlying thinking here is the so-called quality of service. So, for example, if you take resource limits and resource requests and you set them to equal values, you will have a QoS of guaranteed, right? This will be there. You can have the limits setting larger than or having a higher value than the request CPU and memory and above 0, then it's so-called burstable QoS. And if you don't set them, which a lot of people unfortunately still do, then it's essentially on a best effort basis, right? Anything can happen, so we don't give any, or Kubernetes doesn't give any guarantees there. So you really want to have a predictable system, which implies you should and must be setting the resource limits and requests there. Now the question is, where does that come from, right? And I just pointed out 2 blog posts from end users who essentially complained about that, very rightfully so. If you look at the timeline, it's a bit, 2 years or whatever, but it's still very much true that unfortunately there didn't used to be anything there that would help guide users to actually come up with these resource limits and resource requests there. So the goal really is, in a sense, that we can automatically, without any human intervention, figure out what the optimal requests and limits there are, because manually it's just not really manageable. And with that, we have a quality of service or guaranteed quality of service. Otherwise, you end up in a best effort case. On the other hand, we want to improve the utilization. Obviously, the more we can bin back on a certain node, the higher the utilization gets. Of course, there's always a certain, you want to leave a certain headroom. You don't want to go up to 100%, but let's say 80, 90% is great. And you also want to have the impact on the other functionalities like handling or enabling. It's still, I think, not really there, the optimizing scheduler, but is there already PR? I have no idea, but it should enable that as well, hopefully, at some point in time. As already mentioned by Solly earlier on, one typical use case for it is any kind of stateful apps. Think of a database like MySQL or Postgres, or anything that kind of packages that, like WordPress, that under the hood also uses a database. I will point out at this point in time, and you already said it, that given that we have currently no way to in place replace the pod, it essentially means a new pod with the new effective resource limits will be created. This first statement is not entirely true. Right? It is only true if you can actually manage the state in a way that you either make sure that it is scheduled on the same node, or that the data goes where the new pod potentially will be scheduled. There are proposals, or at least one proposal I'm aware of that's together with, or in SIG Node, I believe, where it essentially boils down to, can the underlying container runtime change the C group settings on a running container? As long as that is not the case, then obviously we need to fall back to what we currently have, creating a new pod with the new limits.
But there is a proposal in place, and we
Right.
do hope to eventually have in place resizing.
Yeah, and definitely if someone from SIG Node is around and dares to raise their hand. No? Okay. It was worth a try. No, so this is really something that, at least for me, I mean, when we initially, and it was mainly Google in Warsaw who implemented and drove the implementation there, that was clearly called out, this is a current limitation, a known limitation, but it's better than having nothing. Even the recommendations already give you some guidance there. To me personally, at the current point in time, with the current implementation, maybe the second bullet point is even more interesting, and that is if you have a legacy app, let's call it that. So you have some monolith that you just want to lift and shift into Kubernetes. So you might not have the source code for it, you might not be able to re-architecture it, or whatever reasons, you just take an existing binary or whatever and you put it into a container. And that is something where, in this case, you simply cannot use a horizontal pod autoscaler because there is nothing to, it doesn't make sense to have multiple instances or replicas running in that. But you definitely have, with growing traffic, you have more resource needs, and with that, you would need to allocate more memory and or CPU. And for that, I think at the current point in time, this is certainly something, if you have that case, lift and shift of an existing monolith, where you can't re-architecture, you probably want to have a look at the VP, at the Vertical Pod Autoscaler. A quick look at how this actually works internally. The API server, or the control plane, most importantly has the API server in there. Everything goes through the API server. Everyone talks through the API server, and that are on a principled level the phases there, right? You get a HTTP request with a JSON payload in there. There's some authentication, authorization, verifying who that entity is and if that entity is allowed to carry out that operation, like creating a pod or creating a service. And then this step, the yellow bordered step, this is the place where you have a chance in that flow, in that request flow, to change the actual representation of that respective resource or object in this case, before it actually eventually gets stored in etcd. So here you can, for example, say, the user didn't set any request limits. I know what to do, and at this point in time, mutate, I change the definition of the specification of that resource, for example, the pod in this case, at this point in time, and then I go further on, validate it, and so on, and store it eventually in etcd in the API server. So this is the basic trick here that we are leveraging. So overall, how is that implemented? Obviously, in order to come up with a recommendation, for the resource limits and requests, we need to observe what is that application actually using. And that is done and builds up this historic profile. That's the recommender part. And then optionally, you don't have to, you can apply that. You can say, okay, now enforce that, now set the actual limits. And with that, you would, at the current point in time, create a new pod. And that is on a very high level the architecture there. As you can see, there are a lot of moving components, that is no doubt. I guess part of the motivation for the design was to keep it flexible but also scalable. I don't know if you want to talk more about that architecture at this point in time, or?
Yeah, I can talk a little bit more about it. So the basic idea, like Michael mentioned, is that we have a recommendation engine, and which is kind of the heart. And so the recommendation engine will fetch and periodically update a recommendation based on current metrics. And so it will look at the metrics we have available, and when it starts up, if historical storage is available through something like Prometheus, it will attempt to pull a bunch of historical metrics in via Prometheus. And then as it runs, it will also periodically attempt to pull the resource metrics API, so generally provided by metrics server, potentially provided by Prometheus as well, and update its recommendations. Look at what was used previously and figure out what it should probably be using now, based on how much it's using, how close it is to its limits. And then there's two steps. So the recommendation is always actually applied when a pod comes in. So a pod comes in for creation. It goes through that API server workflow. It hits the mutating admission webhook, which then calls out, looks at the recommendation for that pod, if there is one, and applies that. And so that workflow can be used by itself. So you can just say, when I start up my pods, I'm not going to manually set a request and a limit. I'm going to let the Vertical Pod Autoscaler recommend a request or a limit for me. But you can also say, look for things that are currently under stress, right? And so the Vertical Pod Autoscaler controller will periodically look for pods that are using more than they should be, whose recommendation is off from what they are actually set as, and it will evict them. And then whatever is controlling that pod, whatever owns that pod, say a replica set as part of a deployment, will start a new pod, create a new pod, and it will go through that flow again. And it will hit the recommendation, and then you'll get a new pod with the right resources.
Cool. Thank you. Already mentioned that we're still in a rather early phase. I don't actually know the actual current status with 1.13, but I think it's still not alpha, right? We didn't.
I think it's alpha.
Is it alpha? Okay. Sorry?
It's almost beta.
Almost beta.
I like your optimism. So let's agree it's alpha. Okay, cool. And I think the number one ask here is, especially for people who are already either looking into using it or already using it, give us feedback, right? Any kind of data points that we can get to see in what direction, because obviously the current efforts are around stabilizing that, and once the API is stable, well, you can't really expect changes anymore, right? So now is the time, I would argue, to be loud about it and share your opinions, write a blog post, come to us and tell us.
Especially if you have a use case that's just very clearly not met by the current implementation of the vertical pod autoscaler. If that use case is I need in-place updates, we are aware of that one.
Yeah.
But like if you have something else that's very clearly like, you're like, it looked like the vertical pod autoscaler might work, and then I tried to apply it, and there was just some complete impedance mismatch with my use case, or everything caught on fire and my cluster exploded, like let us know, because we're really interested in those so that we can update our design, change how we think about the problem before we go to beta and GA.
Right. And I guess the majority of formal or informal feedback so far is essentially the experience that Google internally has with Autopilot, where, I don't know, 60% of whatever of the users actually use that, but that is, you can't really translate that one-to-one here. So we really depend on, feedback from the community, from you guys out there to know, is that the right decision, or should we change something there? And now I think we still have time for a little demo that Solly recorded, I think, in an earlier version. Let's quickly look at that. Okay. Do you want to voice it, or? Oops.
You can go ahead.
Okay. So what we see here, hang on, let me. Yeah. What we see here on the left-hand side, it's definitely the other side, is a Kubernetes cluster, and on the other side, the command line interface, and essentially we have something prepared there that we want to use or apply the VPA on. So let's have a look at the actual resource, the statement there, the manifest there. And if you look at, well, you can't really see it nicely there, but the goal here would be the 100 milli CPU and 50 megabytes memory. And so this is the target deployment and the VPA in there in the manifest. And now we essentially apply or create that in the first step. And as we would expect, this example hamster app comes up. And at some point in time, we should see what is going on there in terms of what it actually uses. And after some more time, okay, there you see the actual 100 milli cores and 50 megabytes, right? And now having a look at the status of the VPA. So it is in the update mode auto, which we didn't really talk about a lot, but might have still some time there. That's essentially the policy that you can choose how to go about things. And a little further in, yeah, takes a bit. Okay, and now you see the actual change there, right? So you have, for the recommendation, the lower bound, the target, and the upper bound. That is the recommendation we got out of the VPA there that you can choose to apply, or you might just take that into account and do something manual with it. But at least you have based on the data, a clear indication on what your application actually consumes. I don't know. I don't really think there's much more there, right?
I believe we eventually see the VPA actually apply the recommendation.
Okay, yeah. But let's
speed that up a little bit.
Yeah.
Yeah, and so you can see there that the VPA has applied the CPU and the memory recommendations to the pod. The pod was restarted sometime in the middle of that skip, and we now see things have changed.
Right. Okay, I think with that we're almost at the end. I think it's just a few pointers there in case you do have feedback and want to get engaged. So we do still meet more or less every Monday on Zoom, and there is a rather active now SIG Autoscaling Slack channel on the Kubernetes Slack community, and yeah.
Yeah, we try to always respond to things on SIG Autoscaling. If you find you message someone and they haven't, or ask a question and no one's responded, feel free to mention us. But we try to respond, and we have pretty decent time zone coverage between some of the folks in Poland and I'm out here now, so.
Definitely, if like APAC, we definitely think could need a bit more coverage in this little part of the world, right? So if
it's true. Yeah.
If you're somewhere from Asia, Australia, somewhere in that area, and want to help out or even get more engaged and contribute, definitely, hang out on Slack, join us at the meetings, and.
Some of us do just keep weird hours and respond to Slack messages in the middle of the night, though.
Yeah. Okay, I think that's pretty much it what we had for today. So I don't know how much time we have. 5 minutes? Does anyone know? Is it 5 minutes?
I think so.
I think so.
I
Right?
actually have to jet.
Sorry? 8 minutes. I take the 8 minutes. So then we can actually take questions already today, if there are any, right away. And as I said, tomorrow in the deep dive, I think in the afternoon, 2:30, whatever, there is some more.
All right, I'm gonna just go front to back. So.
Do we have a microphone here? No. Otherwise, I'll just make mine.
Yeah.
Thank you. Okay, so I would like to ask how the recommender works. So how does it analyze this historical data? What happens there? Is this some sort of statistical analysis? Is this some machine learning? Or what happens there?
I think right now it's, I believe it's just looking at the percentage of usage. Are any of the VPA folks in the audience right now?
Basically, it stores the histogram of your usage for the last 8 days and takes a very high percentage of that. So most don't have any machine learning yet.
Can you repeat that, please?
So basically, at the moment, it stores 8 days of usage samples in a histogram, and then it takes a very high percentile of that as your target recommendation. So statistical, no machine learning at the moment, and we're seeing how it pans out.
Awesome. Thanks. All right. So that's, I think.
You have the overview.
Yeah, I was wondering if you guys already consider somehow combination of the HPA and VPA, because definitely that use case.
That's a common question. It works in some cases, especially if you're using different metrics. If you're scaling on the same metrics, then you run into problems because the HPA is going to try to optimize on one axis, and then the VPA is also trying to use those signals to optimize on a different axis. But I think there have been a couple of users that have had limited success in scaling on different. So they might scale on HPA on requests per second and VPA scaling on memory or something like that.
Yeah, for us, by the way, I'm from the JD.com. We are running one of the largest Kubernetes cluster in production. We have 500,000 containers, so autoscaling is very important. So one use case for us is more, yeah, we like the VPA and it's simple, right, easy for stateful application, but sometimes it's limited, constrained by your local resource, right? You cannot scale it unlimited. So we could do the VPA sometimes, but up to a certain limit, then we have to do, the HPA. I just think maybe architecture framework perspective, can consider, have a unified framework.
Yeah, I think that's definitely an interesting use case. It's I don't think an architecture that we support right now, but it's definitely something to add to the list of things to look at in the future.
And I definitely would encourage you to write up stuff if you can, share stuff, either
definitely
blog post or whatever you can.
Blog
the
posts,
more
Google Doc.
That would be awesome.
If you guys have a design that you think would be awesome, like you could even submit that as a KEP, a Kubernetes enhancement. Depends on what you have and how much time and resources you can allocate.
And what you can share.
Yeah.
That would be awesome.
All right, who else had questions? All right, so back there.
Hi, can I ask a question about HPA?
Sure.
Is there plans or future plans to add the feature to scale to 0 and back up from 0?
Oh boy. Yeah, so that's a fairly common question. There's not a plan right now. Scaling to 0, it turns out, is very tricky because it's really hard to scale back from 0. And accidentally scaling your app into a place where it just gets stuck and then sitting there for a while is not conducive to not getting paged at 3 in the morning, which is one of the reasons we've avoided it thus far. The other reason is when we started out with CPU, it's hard to scale on CPU to 0 because CPU never really goes to full-on 0. It is something that people have asked about before, and if you have a good design that you think would work well, I'd love to hear it. So please get involved.
I don't know if you're just being shy, or doesn't Knative do that somehow? No. Yeah. I think that might be an option, right?
Yes.
Yes. We'd make sure 1, 2, 3, just to make sure. Oh, you didn't have. Okay.
Hello. So, one of our biggest blockers from to moving to Kubernetes is scaling down our pods, and we have pods that are performing critical operations and cannot ever be shut down arbitrarily. I noticed a similar problem with the game server guy, where they had to, it was interesting, they had to do their own, I think, replication controllers and their own CRDs to solve a simple problem. I want you to scale down, but this pod and this pod do not touch, please. So we have exactly that use case. Is that something you've thought about, or you have options for me on how to solve?
So if you don't want particular pods to be auto-scaled, I would put them in a different, managed under a different object. Maybe I'm misunderstanding your use case.
Okay, so we have, let's say we have a worker, we have a queue and we have workers working on queues. Once they pick up a job, I don't know how many are going to work. Once they pick up a job for an hour,
yes. So
the queue decreased, yes, but there's still 2 of them out of, let's say, 10 that are working on it for an hour or 2 hours. I still want to kill 8 of them because they're wasting my money. But those 2 should wait until I say that they're done with that critical operation.
So there's a couple ways to deal with this. Depending on how long your critical operation is, you can always set liveness and readiness, and then also make sure to set termination handlers. But that doesn't always help in your use case.
It's not ideal. That's our only option.
We also have some priority features. We could probably improve those to deal with that use case a little bit better. Come talk to me at the deep dive if you are able to make it, or send me a message, because that is something that we could deal with a lot better.
Can you put them into different namespace and tell that Autoscaler don't touch that namespace?
Well, but you won't always know, right? Like if you're to go back to the original question, right? You have some number of workers that are part of the same deployment, and they're pulling items off of a queue, and you don't want to kill the ones that are currently processing things, so you can't just dynamically move them to a different.
But you can start like, you have a burstable in one namespace and constant in another, and they just process the same queue. If queue abstracted
I don't have
outside.
anything constant.
Yeah, you don't necessarily want, like,
I thought that you said you're talking about tools and that has to be.
it might be two. It might not necessarily be specifically two. It's just whichever ones are currently
But
actively
still
working on the
question,
workload.
Can Autoscaler be told that don't touch that namespace?
I mean, you create an individual autoscaler object targeting a particular scalable, so a deployment or whatever. So you can always just not create an autoscaler, right? But in the case where you don't necessarily a priori know what your pods are that you don't want to touch, it's a little bit harder.
I think it's really about influencing pod direction. Like, we don't want the system to pivot pods that are in a state that is critical to them.
So right now, we don't have a great signal in Kubernetes to indicate that is part of the problem.
Is there a plan around it?
There is not a plan that I know of off the top of my head, but that's certainly something worth investigating. All right.
Actually, I just wanted to point out, I'm the Autoscaling working group lead for Knative, and so if you want to talk about scale to zero, running HPA and VPA at the same time, or we deal with the work in flight problem as well. So we have like hooks so that existing HTTP requests will finish before we kill a pod. Yes.
Yeah, you should.
Oh, I don't know if I'm going to be at the deep dive. I have a talk at 2:35 on autoscaling on Knative. Tomorrow, 2:35. Yeah, it's called Zero to Infinity. Yeah.
Let's have lunch together.
Yeah, sure. I think that sounds great.
Awesome. Thank you so much. Cheers. All right. That's it. See you tomorrow at 2:30, right? Thank you.
All right.